Okay, guys. Today we are talking about linear systems. Now, we've had linear equations. That's equations with two variables, and those variables are raised just to the first power. So something like this: y equals 2x plus 1. That's a linear equation. Or we could even do it in standard form and just make it 2x minus 3y equals 6. Okay, that's another linear equation. Now, the thing we know about this is that when we graph these two equations, they make a line. Excuse me. And that line, that graph, is the picture of all of the solutions to that equation. So let's just do this quickly. I'll just draw a quick little rough graph here. And this first one, y equals 2x plus 1, it has an intercept of 1. It goes up 2 and over 1 to about right there. Maybe, I could have done that a little better. Alright, and there's the line for that one. Now, let me change this one. This is going to be negative 3y is equal to negative 2x plus 6. And then I divide everything by negative 3. Alright? And I'm going to get y is equal to 2/3 x minus 2. Alright, so now this equation is going to be down here at minus 2. That's where its y-intercept is. It goes up 2 and then over 3 right here. And so this line, whoa, let's see there, that's better. That's better. Okay. This line goes about right here. Now I'm going to extend this line just a bit so that these two lines intersect. And at this point where they intersect, okay, that's an intersection point, obviously, and that point is on both lines. Now, earlier we said that a graph is the picture of all of the solutions to the equation. So the red line, it's a picture of all of the solutions to this equation. And the green line is a picture of all of the solutions to this equation. But this blue point is very special. Okay? I'm going to put a little swirly star around it, because that point is on both lines, which means it's a solution for both of those equations. And that's what we're trying to do with linear systems. We're trying to find that common solution for the two equations. Now, let me clarify this name up here, linear systems. Linear system is just when we're talking about two or more equations in the same variable, x and y in this case, and that we graph on the same line, on the same coordinate plane. And we're looking for, like I said, the common solution to these two equations. And if I graph them, I see the point where they intersect is the common solution. Now, what we're going to find out today is it's hard to graph because it has to be perfect. The graph has to be perfect to figure out what that intersection point is, and so it's difficult. But we have two other methods of finding that intersection point. One's called the substitution method, and the other one has a couple of names. I'm going to call it linear combinations, but also elimination method is another way of finding that common solution. So I hope that that's clear about what it is that we're trying to do here. Today we're going to do some graphing of the two equations, and just trying to do that as clearly as we can so that we can get an intersection point, and then we'll test that intersection point to make sure that it solves both of the equations that they gave us. Alright, well, let's get started.